Hello everyone, welcome back. And today we're gonna keep doing chapter one and functions and rotations. And today might be the last chapter for chapter one. Most important part is the power functions. So if we try to do the power functions, and we know you're definitely gonna have a power, which is the some like rational numbers. That's why I'm circled R, which is x to the power of R. R can be any rational numbers. They call power function. So, for example, x to the power quartic, x to the power 1/4, or x to the power of -5, they all can be the power function. So, increasing or decreasing function, they all can be. Or first thing I want to introduce what's the strictly increased. So, if I had two random x1, x2, we can clearly say x2 in the function of x2 is greater than the function of x1. So that means it's increasing. Decreasing opposite way, which is like if you had x2 less than x1, and then your function of x2 less than x1 as well, that means a decreasing. So power function of the positive integer index. So we can say x is linear to the parabola to the cubic functions. They all nearly closest to the y values, right? So from here to here and to here, and maybe keep going until you nearly hit to the y. So there might be. All right. So first important thing I want to talk about is x to the power n. N is positive odd integer number. Okay, all integer number. If it is all integer number, they can be increased and always gonna be increased. 1 to 1 function. Okay, 1 to 1 function. So if f0 equal to 0, f1 equal to 1, f negative 1 equal to negative 1, so we can say the function if x to the infinity, positive infinity, fx to the positive infinity. If x to the negative infinity, your function of x will be going to the negative infinity. So if function fx equal to x to the power n, n is positive even number. So the function will be even function, and the function will be strictly increased if x is greater than equal to 0. Okay, very important. And if that's decreasing, that means your x is less than equal to 0. Sorry, less than 0, not equal to. Okay, make sure. And x positive or negative infinity is actually goes to the positive always for the functions. And f0 equal to 0, f1 equal to 1, f negative 1 equal to 1. So we know that can be like the quadratics, can be quartic values if you're graphing. Okay. All right, most important part, keep going. Power function with a negative integer number now. So if I had x to the power n, n is odd negative integer number. So fx is x to the power -1 is 1 over x. And if that's a 1 over x, and then your graph will looks like that. We have some asymptote now, so which is horizontal asymptote and vertical asymptote. That both x and y are equal to 0 is your asymptote. A range actually is all real number except for 0. Yeah. And also function is odd number. All right, so sorry for the mute, and we come back with some examples. This example is actually showing you fx equal to 1, so 1 over x to the power 5. So maximum domain and the corresponding range. If we know this one, actually, we could do question A, the maximum domain is real number, but except for 0. Perfect. And your range is equal to the real number except for 0 as well. So as I said, this one is odd number and also is negative. Okay. So substitution the values, only substitution maybe 2, okay, 1 and 4. So 1, if f(x) equal 2, that equal to 1 over 2 to the power 5 equal to 1 over 32. So we can say your Cartesian plan, or we can say the point is actually equal to 1 over 32. That's the first one. And second one, so if x equal to negative half, that equal to, sorry, move that away. So that equal to 1 over half to the power 5. And that's 1 over 32, a negative. Okay. So that means a negative 32 coming up. And then when x equal to negative half, that's equal to negative 32. Perfect. You can do 2 and 3 by yourself. I'm going to skip that one. And then I'm going to sketch the graph with your calculator, without your calculator. Okay. Interesting question. Result. All right. So first thing, draw the horizontal line. As always, we know perfect x and y, perfect x and y. And so our line is when x equal to 1. So fx equal to 1 over x to the power 5. So when x equal to 1, your y equal to 1. Perfect. And then when x equal to 2 is very close to 0, we can say, right? That's our point. So we could do is closest to very, very like a right angle triangle, but it's like that. Perfect. Like that. Looks nice. Close enough. And then this one will be, do not touch that line. Perfect. Keep going that way. Perfect. Good. So that means when y equal to 1 over x to the power 5. Perfect. You only can show maybe negative 1 to negative 1 in here. So 1, negative 1, 1, 1. That's it. That should be perfect.